Okay, now let's do a more complicated one. So this time, still kind of the same idea as before. We're still letting the attacker control the 0th argument to printf, the one with all the formatters. But this time I'm going to put the buffer on the stack instead of in the static part of memory. And that's just to show that I can make more complicated things happen. So let's draw the stack diagram. So what has to go on the stack? Well, whenever I open up a new stack frame, I have to have the RIP of vulnerable and the SFP of vulnerable. Those are my two saved register values. Then I'm going to have the local variables buff and string. And then, let's see. And then I'm going to open up a stack frame for printf. And printf's going to have an argument that's buff, RIP, SFP, and then its own stack frame. So to make a long story short, it looks like that. When I open up vulnerable, I have RIP, SFP. I define the local variables of buff and string, or str. And then when I call printf, that opens up its own stack frame. So I pass in the argument buff. And remember, arguments are passed in as pointers in C, or rather, arguments to character arrays are passed in as pointers. So I pass in an address, and the address points at buff. Then I open up the printf stack frame, has RIP, SFP, and printf. And usually when I show people this, the first thing they ask is, well, what happened to the fgetS stack frame? Well, remember, when we execute this code, we execute it line by line. So we execute fgetS, and when fgetS is running, it opens up a stack frame, does all the things that fgetS needs to do, but then fgetS returns. And when fgetS returns, its stack frame is totally cleared out. And then we get to the next line and we open up printf stack frame. So because fgetS is called first, and then it returns, and then we call printf, there is no stack frame for fgetS that's active right now. It was created earlier in time, but it has been destroyed now. And I only care about the stack frame while printf is being called. So just in case someone was confused about that, that's why fgetS doesn't have a stack frame. Not the most important detail here, but something that people ask. Anyway, now we're in printf. And printf sees this buff. And whatever goes in there, if it has any percent formatters, printf is going to have to match them up with arguments. So where does printf look for arguments? Remember, we always push arguments on the stack. So what that means is printf is going to go on the stack, and anytime it sees a percent formatter, it's going to match it up with some value on the stack. So specifically, it's going to match them up like this. And I've numbered them for you. So the 0th argument, the one that has all the percent formatters, that's right here. And if there's a single percent formatter, it will have to match up with this memory box right here. If there's a second percent formatter, it'd match up right here. If it has a third one, it would match up with this one. If it has a 4th percent formatter, that formatter would match up with this box on the stack, and so on and so forth. So each of these on the stack, printf thinks there's an argument there, even though it's not actually an argument. It's just stuff that was already there. So this is where printf is looking for arguments, and I've labeled them with these arg numbers just for our convenience.